Okay. Now here's an instance where, I talked about it before briefly when we were doing a lot of figures on the coordinate plane. Um, you know, Thinking that, when I started going into y over r's and x over r's, the numbers we were putting in there were coordinates but they're still essentially ratios. Those ratio measurements are not necessarily what the actual values are supposed to be. And here's what I'm talking about here. I'm given this right triangle is labeled. We want to find side B, which is the same thing as side AC here. It's opposite angle B. We know that the sine of A is 4/5, and we know that A itself is 12 inches. So a big mistake that students make with this is they think, okay, well, A is going to equal 4 inches. The sine of A is 4 over C. And since the sine of A has to be 4 over 5, then C has to be 5 inches, and they go with A's being the measurements. That's not the measurements because we were told explicitly that A is not 4 inches, A is 12 inches. So make sure you're obeying what it tells you. So, eventually. But that's not the right answer because, it's working with the assumption that A is 4 inches and C is 5 inches. Meanwhile, we're told that A is 12 inches. So what I have to do is look at it from this standpoint. A is given to be 12 inches. B and C, I don't know what they are. However, I do know the sine of A, which is A over C, is 4/5, and I know that A, you know, 5A equals 4C. A is 12 inches, so 5 times 12 equals 4C, which means that C is going to be 15 inches. Now, with that information, I can use that to find B using the Pythagorean theorem, and I get that B equals 9 inches. So you have to make sure you differentiate between ratio numbers, again, the actual measurements, are the opposite leg and the hypotenuse.